Chapter 2, Section 2.1, Functions and Their Graphs, Part 1. So here we have a fill-in-the-blank question. A blank is the mapping or pairing of input values, called the domain, and output values, called the range. So here we want to put in relation. So a relation is the mapping or pairing of input values called the domain and output values called the range. So here in example 1 we have a set of input values, those are our domain values or our x values, and then a set of output values, which is our range or our y values. Same in example 2, we have a set of input values 0, 2, 3 and a set of output values 3, 2, 1. And we can see that each input is matched with a corresponding output. We're asked here to write the above mappings as ordered pairs, where the first coordinate is the x value, or the input value, and the second coordinate is the y value, or what's known as the output value. So in example 1, we can see our set of order pairs is going to be 2, 1, 4, 1, -1, 2, and 3, 2. In example 2, our order pairs are going to be 0, 3, 0, 2, 2, 2, 2, 1, and 3, 1. Example 3 gives us a list of order pairs, and example 4 also gives us a list of order pairs. We want to answer the question, what is the domain of example 3? So we want the domain, we want the x values. So our x values in example 3 consist of the numbers 2, 4, -1, and 3. And then we'll list those from least to greatest. So we have -1, 2, 3, and 4. What is the range of example 3? So here we want the y values. And we'll look at, we have 1, 1, 2, 2. So our range values will be 1 and 2. So if they repeat, we only have to show them one time. What is the domain of example 4? So we'll go back and look for our x values. We'll put them in order from least to greatest. We'll have 0, 2, and 3. And what is the range of example 4? We'll look at our range values, and that will be 1, 2, and 3. Plot the coordinates of example 3 on the coordinate plane. So we want to plot the first point, 2, 1, 4, 1, -1, 2, and +3, 2. Plot the coordinates of example 4. So we have 0, 3, 0, 2, 2, 2, 2, 1, and 3, 1. Here we have a relation or mapping is a blank if for every x value there is one and only one y value. So we're going to fill this in with function. A relation or mapping is a function which of the two examples on the previous page is a function? So if we go back and look at example 1 on the previous page, we can see that our coordinates 2, 1, 4, 1, negative 1, 2, and 3, 2 meet the criteria for a function. So example 1 would be a function, right? Because each x value has only one and only one y value associated with it. If I look at example 2, I can see that 0, 3, 0, 2, 2, 2, 2, 1, and 3, 1 is not a function. 0 is matched with 3 and also with 2, and 2 is matched with 2 and also with 1. So therefore, that is not a function. Example 3, that would be a function. So we have example 1 as a function, example 3 is a function, and if I look at example 4, again, I have 0 matched with 3 and 2, and 2 matched with 2 and 1, so therefore that would not be a function. So only example 1 and example 3 would be a function, based on our definition. A graph of a relation is a function if it passes the vertical line test. Any vertical line drawn through the graph passes through it no more than one time if it is a function. So in example 5, we have another set of input values and output values. We want to write those as a set of ordered pairs, which is going to give us 2, 3, 5, 3, negative 1, negative 2, and 6, negative 2. What's the domain of that set? So the domain here will be negative 1, 2, 5, and 6. And the range will be negative 2 and 3. Graph the relation on the plane to the right, and then determine if the relation is a function. So if we plot these points, and we perform the vertical line test, we can see that we're only going to hit one point when we go through the graph. Check those points that have been plotted here. They're only going to hit this relation in one point at a time. And we can see our domain is unique, right? Each x is matched with only one y value. So here we would say that, yes, this relation is a function. We're going to create a table here to graph y equals x plus 1. We'll pick some x values to substitute. We'll pick negative 1, 0, 1. You should probably pick a negative, a positive value, and 0. We're going to substitute that into y equals x plus 1 and determine what our y value is. So if we substitute, negative 1, we'll get 0. If we substitute 0, we'll get 1. And if we substitute 1, we'll get 2. We'll plot these points. And we'll draw our graph, which is the graph of a line. Is it a function? Yes, it passes the vertical line test. The vertical line will only hit that graph in one point, so yes, it is a function. Below here are the last two examples. Create a table to graph f of x equals x squared. We're going to use the points negative 2, 1, negative 2, negative 1, 0, 1, and 2. We'll substitute those in. That will give us 4, 1, 0, 1, and 4. Remember, we're squaring a negative. That will give us a positive. And we can see here, we have the graph of a parabola. This is a function, passes the vertical line test, right? Each x is matched with its own y. So we would say, yes, it is a function. Here we want to graph x equals y squared. So this time we're going to put y values of -2. So sometimes it makes sense to substitute for y. Y is squared. That will give us solutions for x this time. And we'll plot these points. And we have a parabola again. However, this will not pass the vertical line test because we wind up hitting the graph in 2 places. So this will not be a function.